You're listening to the Skeptics Guide to the Universe, your escape to reality.
Hello and welcome to the Skeptics Guide to the Universe. Today is Wednesday, February 19th, 2025, and this is your host, Stephen Novella. Joining me this week are Bob Novella.
Hey, everybody.
Kara Santamaria.
Howdy.
Jay Novella.
Hey, guys.
And Evan Bernstein.
Good evening, everyone.
Happy Pluto Day.
Yes. A happy day after Pluto Day, but, hey, we can still celebrate it today.
Absolutely. It's Pluto week, actually.
Really?
I agree. Yeah. It deserves an entire week. I mean, what the heck? We stripped it of its full planet status. We might as well give it a full week.
But it is the first and the largest dwarf planet.
Yeah. That's right. The king of the dwarf planets.
They tried to make everybody feel better, saying, we'll call them Plutoids, which nobody does.
Yeah, right. I see that once in a while, but yeah, it's not very common.
I mean, so I read this yesterday, but it's Pluto Day. And I was thinking, does that mean on Earth or on Pluto?
Pluto.
Because we're not going to celebrate that thing for, another 300 years before it comes around? But it is Earth-based, yes, the celebration.
Yeah, it still hasn't done a complete orbit since it was discovered.
Really? I mean, it's an amazing thought. That's how far out that dwarf planet
What
is.
are we celebrating, though? The fact that we're failing the Earth miserably?
Oh, Jay,
yes, and
not
only that, but Pluto Day is celebrated on February 18th to commemorate the discovery of Pluto, which was made in 1930.
Yeah, there you go.
Okay.
By astronomer Clyde Tombaugh, who discovered Pluto at the Lowell Observatory in Flagstaff, Arizona.
I've been
What
there.
I'm surprised about?
There you go.
What? About having to do with the dwarf planets? I'm surprised that there are still only 5. I thought we were going to be adding dwarf planets on the regular, because there's so many objects in the Kuiper Belt. And why only 5? We haven't been able to confirm a single one.
Yeah, that is kind of
We
weird.
found thousands of exoplanets already in recent years. You're right. Why aren't we finding these items, these
They're
objects?
probably harder to find.
Is it that they're not confirmed or they just haven't gone through the motions yet?
There's a lot of candidates out there. I don't know what's
Yeah.
taking them so long. There's just the same 5, so who could name them? Pluto, Eris, Haumea, Makemake,
Makemake, I know that one.
and Ceres. That's in the order of size. Ceres is the smallest one. It's in the asteroid belt between Mars and Jupiter.
It's so close.
So Ceres is interesting because it was a planet, then it was an asteroid, and now it's a dwarf planet. I think it might be the only object in the solar system that at one time or another was designated as all 3 of those things.
When was it designated a planet?
Initially, when it was first
Early
discovered,
on,
they're like,
yeah.
it's a planet. But then they said, we'll just... Then it was like, all right, it's actually in the asteroid belt, so we'll just say it's an asteroid. And then when they made the category of dwarf planets, they got upgraded from an asteroid to a dwarf planet.
I have a question about dwarf planets. It has to do with their moons. Now, Pluto has 5 moons. Charon, Nix, Hydra, Styx, and Kerberos.
Cerberus.
Cerberus.
It's a 3-headed dog.
With a K, but yes, Cerberus. Are these dwarf moons around a dwarf planet, or do we still call them moons around
They're just
a dwarf
moons.
planet?
Are any of their moons bigger than their planets?
That's no moon.
No, but Charon is an interesting one. So Charon is
It's a huge
big enough that you could
double
argue
planet,
that it's a double planetary
dwarf.
system or a double
Dwarf.
dwarf planet. Charon could be, we could decide, hey, this is actually another dwarf planet, and Pluto-Charon's a double dwarf planet system. I believe
That'd
that
be interesting.
the center of gravity between Pluto and Charon
Very
is outside the surface of Pluto, which is something that you could use as a criterion for determining.
That's not a,
that.
that's not a bad.
Are there
Bad
binary
criterion.
planets? Is that what we would call it? Or is it not quite like a binary star system?
Binary dwarf system.
Binary
I
dwarf
guess.
planet system?
I mean, you could make an argument that the Earth Moon system is some sort of binary. Binary. I mean, the moon is huge compared,
relative to its planet.
Yeah,
correct.
big.
Yeah.
But it's still tiny. I mean, is it bigger than Mercury? Wait,
Pluto?
boy.
No, our moon.
No,
There are moons bigger than Mercury.
Oh, yeah, there's some really big moons, like around Jupiter, right? And Saturn.
Titan.
Hence the
Titan
name,
would be
yeah.
largest, yes.
Mercury is slightly larger than the moon, not much.
Ganymede,
Not
Titan, Callisto, Io, and Earth Moon. Earth's moon, this is the reference of reading, are all larger than Mercury.
In that order.
Oh, but Bob just read that it's not bigger.
Our moon just got to be close.
Yeah, this is this one site saying that Mercury is slightly larger than the moon.
How do you feel about causing a scientific controversy right on our show right now?
Well,
the SGU is officially designating Charon as a dwarf planet. Change my mind, or change our minds.
Yeah, we'll write a letter to the International Astronomical Union to inform them of this change.
To inform them
that we've
yes,
made a
right.
decision.
Not inquire, not request.
To inform them.
We will slap him in the face with the fact.
Hey.
All right.
If Trump could rename the Gulf of America,
oh my God!
Right?
We can rename.
Don't use that
Charon
name,
the dwarf.
Steve.
It says so right on my map
Don't
here.
give him
Gulf
any
of
ideas,
America.
man.
So in some of the maps.
There's no international rules anymore. We just could name stuff, right?
That's right. Exactly. So let's go, Charon.
Every time you
Dwarf
say Charon,
We've just discovered the sixth dwarf planet. Thank you. Carrie, you don't seem on board with this.
Nope.
The controversy is not.
Stop normalizing it.
Oh, no.
Oh, so we have to follow the rules.
Yes.
Is that what you're saying?
I'm going to make Charon great again.
When they go low, we go high.
You know what that means? That tells me it's time to go on with our news items. We're going to start by talking about bird brains.
Ooh.
Who?
I'm talking about bird brains.
No, I mean, which person are we talking?
Yes, that's right. So the question, we all know that humans have the biggest and best brains, right?
Well,
but it's interesting to think about the fact, though. This is one of those evolutionary misconceptions that I had when I was younger that had to be beaten out of me by, reading good science communicators about evolution. Like, we tend to think conceptually of, humans have the biggest brains, and chimpanzees are close, but they're not as big as ours. They don't have, as much sophisticated language, et cetera, abstraction as humans do. And then apes generally have bigger brains, more encephalized, if you want to call it that, encephalization quotient, than other primates than other mammals than other vertebrates, right? But we tend to think of the current extant animals as if they are frozen in evolutionary time, right? Meaning that as you look back evolutionarily at our ancestors, that's not the same thing as looking across modern extant species.
Tell that to 23andMe.
So our common ancestor with all primates is not a modern primate, right?
Yeah.
So what that means in terms of the evolution of brains is that, for example, when we divided from our last common ancestor with birds have spent just as much time evolving as we have.
Right.
Right? Their brains are just as evolved beyond that point as our brains are. That doesn't mean that they've developed as much neuronal density or sophistication or whatever, or same specific abilities that we have. But we shouldn't think about, we shouldn't think of them as if they have the brains that their ancestors had millions of years ago.
No, I can imagine their flight mechanics and all sorts of cool things have evolved a lot more.
Yeah, of course.
Well, sure. And the environmental factors alone have had an impact, I'm certain.
That is what evolution is.
Right, exactly. Like even bacteria are just as evolved in terms of they have spent just as much time as evolving as we have.
Yep.
What about sharks?
Same thing. When we think of that's a living fossil, that group has been around for a long time. When we say that, we say sharks have been around for a long time, but it's not the same sharks, right? It doesn't mean that they haven't evolved.
And if we don't see a lot of,
they always say with that sentence with minimal changes, very little change.
It's because they're talking about their morphology.
Yeah,
they're
talking
if you
about
look at them, they look the same.
Gross fossilizable morphology.
Yeah.
That doesn't mean they have the same immune systems that they had 100 million years ago or whatever, the same physiology.
And even if they haven't changed that much, they have been evolving. They just might have not had as much environmental pressure. Mm-hmm. The oceans might not have changed.
That's
as much.
the other bias is that we tend to think of evolution as progressive,
right,
when it is not inherently progressive. This was the fight that Stephen Jay Gould had. He's like, evolution, there's no inherent tendency in evolution for increased complexity or increased sophistication or, whatever, being more advanced or less primitive or however you want to conceive of it. It's just adaptation to the local environment.
Yep, that's
and
all
that could be a totally horizontal thing, a lateral move, Or it could even be, in some cases, like with parasites, a simplification. You may get more simple. It just depends on whatever the local adaptation, the local environment requires.
But couldn't you quantify the amount of change of evolution based on the amount of pressure, the selective pressure that existed through much of
that is definitely a thing. But if you could also look at the amount of change as the number of mutations.
Right.
And that's pretty
That's probably more accurate.
Yeah.
Because we can't look back. We don't know how the environment changed. We have to make all sorts of inferences on that.
It could just mean, Bob, they're basically using the same strategy that they were using 100 million years ago. So they've sort of made the same anatomical, compromises, but that doesn't mean they haven't been adapting the whole time. Right. Anyway, so when we think about like bird brains have evolved over the last 100 million years, just like mammal brains have. They've just evolved differently. So when we compare brains across like mammals, birds, and reptiles, for example, and there's a recent study that did this, which is why I'm talking about it, we could say, well, what things do they have in common and what things do they have that are different? And this is another evolutionary question that comes up all the time. For functions that look similar, are they analogous or homologous, right? Mm-hmm. Is this convergent evolution, or did their common ancestor have that feature? That was basically the question that they were asking. And this is just as a way of helping us understand the evolution of brains and vertebrates, and also just how the human brain works. So what they found, the name of the paper kind of gives it away: Evolutionary Convergence of Sensory Circuits in the Pallium of Amniotes. I love genuine technical jargon like that.
Pallium. Where it tells you exactly what you need to know.
Yes. Yeah. And you would just have to say, okay, what does convergence mean? What does pallium mean? What are amniotes? So amniotes are a subset of vertebrates that include reptiles, birds, and mammals. The pallium is the gray and white matter that sits on top of the more primitive deep brain structures. So it's basically the cortex, right? The cerebral cortex, which sits on top of the cerebrum. So this is the thing that greatly expanded in mammals and then massively expanded, like the neocortex specifically in apes and then humans. Right, that's the pallium. And they're saying, all right, now is the pallium of reptiles, birds, and mammals organized in the same way? And for those circuits, right, those specifically looking at, I guess, sensory circuits here, that look the same, are they convergent or are they derived from a common ancestor? So how can we get at that question? It's always fascinating too. It's like, well, how do we know? How would we, right? Because by definition, they look the same, right? So that doesn't tell you if
genetic markers.
So one is genetic markers, but specifically, we can look at which genes are building those circuits, right? So if they're all derived from the same set of genes, then we could say, well, they probably then have a common evolutionary history. Yeah. They started out the same, they just evolved in different directions. But if they are using different genes, then they probably evolved completely independently, right?
Yeah, sure.
The other way to look at it is more of an inferential method, but you could look at developmental biology. So there's the genetic method, just saying, well, which genes are active here? Is it the same genes or different genes? You could also say developmentally, are these structures coming into existence in the same time and location developmentally, right? Because again, developmental biology, to some extent, is a historical record of evolutionary history. It isn't exactly, of course, but for example, this is always like one of my favorite examples. I think it's very telling. The middle ear bones develop from the jawbone. That's because they evolved from the jawbones, right? That's why they developed from the jawbones. So it's the same thing. You could say, are the neurons that are making these circuits in the pallium the same neurons developing at the same location and time across these different groups? And they found that they're not. They're different.
Okay.
So they're using different genes, producing different neurons at different times in the developmental phase, but making the same kinds of circuits that are doing the same kinds of things. So what they conclude from that is that birds independently evolved a lot of these, convergently evolved a lot of the same sort of neurological function that mammals did, mammals including humans, right? Part of the reason why they're focusing on birds in this study is because some birds are very intelligent,
Man,
but of course,
crows?
intelligence.
Ravens?
The corvids, they're very, very, good problem solving abilities. But and we've talked about this also. Just if you look at like bird neurological ability, their cognitive abilities, it's different than mammals, right? It's still advanced, but their brains evolved to solve different problems in a different way.
Yeah, like birdsong is something we would never be able to master.
The way, yeah, right. The
way that they can mimic and react to different birdsong and recognize these like mild differences. That's just, we didn't evolve with that need.
Same thing with cetaceans, like dolphins. Mm-hmm. They have really big brains, but they're very different than ours. They have way more white matter compared to gray matter than we have, because those white matter tracks are processing all of that sonar.
Yeah, and they can sleep with one hemisphere at a time. That's cool.
Oh, no,
we can't do
really?
that. Yeah, it's
Steve,
absolutely
can we have any real understanding about what their conscious minds might be like?
Not really. We can't know what it's like to be a dolphin.
No dolphin whisperers.
We can infer it maybe from understanding their neurological function. But what do you think is the most advanced and different central nervous system from humans on the planet?
Octopus.
Yeah, that's a great guess.
The octopus has a donut-shaped brain that wraps around its esophagus. But here's the coolest thing. They have about as many neurons as dogs do, but a lot of their neurons are in their tentacles.
Yeah.
So to some extent,
brains in their arms.
Their tentacles have the capacity for independent thought.
Yeah, that's cool.
Wow.
Think about that. So that's like a variable you would not have even thought of. This is like science fiction. It's like your brain is more distributed than our brain's a central nervous system. It is central. It's in one place, your brain. They have a distributed central nervous system in their tentacles. Their tentacles are kind of thinking independently.
Steve, an octopus could give itself a reach around, and it really will feel like somebody else.
There you go. That's the bottom line.
That's the most important takeaway
from the whole thing.
Good night, everyone.
Related to what Jay just said, I just saw an awesome meme today showing an octopus. It said, if a female octopus is hungry and doesn't want to mate, but the male tries to, she'll let him insert his mating arm and begin the process before inching closer to him. Then she'll strangle him, kill him, and feast on his corpse in her den for a few days.
Hell yeah. Get it, girl.
Hell yeah.
That'll learn you.
No, I sent that to Liz as soon as I saw that. But,
how's that tentacle brain working out for you now? Men think with their testicles. Is that the same thing? No, that's not.
Steve, do you think that they have the neurons there because they need to have like a quicker response to their tentacles to do it, right? I don't know. I mean, what would be the benefit of that?
So they need more functionality. They need quicker reflexes. Absolutely.
Well, and there's 8 of them.
Yeah.
So just the sheer number of them doing all different tasks, they made.
Yeah, that's the other thing. They could do things. That's right. They could function independently. There isn't one brain controlling 8 tentacles.
We know what happens.
8 tentacles controlling themselves.
Yeah, like if you do that fun thing where you kind of turn your right foot over and over in a clockwise fashion, and then you try to like draw the number 6 with like your left arm or even with your right arm. Actually, it's really, really hard to do.
That's because of synkinesis. So our brains have trouble coordinating 2 limbs, right?
Right.
Because we tend to we trick it out by syncing them together, and they're wired together in the brain so that we can coordinate them. But it's hard. It's challenging. Imagine doing 8. So that makes sense. That's maybe the primary reason why they're distributed in their tentacles. But it also makes me think of if and when we do encounter alien intelligences, we have absolutely no reason to think that they would be even recognizable to us.
Yeah, exactly.
Oh my God!
Exactly. Little gray men, please. This is
the biggest contrivance, I think, in science fiction, which we kind of know and look past.
Yeah.
It's like not only are aliens humanoid, they have 100% human brains. Yeah. But the chances are overwhelming, even with a little bit of convergence, or even if we're selecting them for technological species, that they would be so neurologically distinct from humanity that it would be challenging to even interface with them. I think like the movie Arrival is one of the best for like showing
that's a good
my favorite sci-fi movie.
Yeah, a genuinely alien, including a neurologically alien. That.
And what's funny is it's a bit octopoid, if we're going to be honest. Yeah,
there you go.
Ted Chiang, the author, one of my favorite authors of all time.
Yep.
Yeah.
Well
I just
written.
wish he was more damn prolific.
Yeah, what the hell?
Was it called The Story of Your Life and Others?
Stories of Your Life,
Yeah.
and also Exhalations, his other anthology. Super highly recommended. But I need more, man. He's got little things here and there, little short stories, a couple of them. But it's like, dude, I want to just like... never mind.
A good way to think about how different aliens would be is the fact of what we were just talking about, how brains evolved on Earth at the same time. And there's huge variability in the way that their consciousnesses function, right? So, an alien on another planet in a completely different, series of evolutionary steps, it would be nothing like humans. It wouldn't think like humans. And like the movie Arrival, like it could take an incredibly long time just to find some common elements that we understand as mutual. You know what I mean?
Right. We might have an easier time communicating with an octopus.
Yeah. And they could talk to the aliens for us.
Yeah.
Or mating with an octopus.
Right. Of course, the other icon of science fiction that got this exactly right was Star Trek with the Horta.
Yeah.
Silicon-based, yeah.
All right, Jay.
Don't see that often enough.
Tell us about air pollution inside our homes.
So a lot of people, by default, and I'm one of them, think that, if the outdoor air is clean, then the indoor air must be clean as well, right? Because you just think, okay, that air, there's an air exchange, and, like when the Canada forest fires were happening and the air quality outside was really bad. Well, the air quality, I knew at the time was bad inside the house, but was it equally as bad, or could it even be worse under certain circumstances? And the answer is yes to everything, right? It could be anywhere, and we don't know. Most people have no idea what the air quality in their house is. But we have new research that came out from the University of Birmingham. This was published in Scientific Reports, and they found that indoor air pollution can be significantly higher and more unpredictable than outdoor air, even when the outdoor air is actually high quality. What they do is they use low-cost sensors, and it's a pretty simple solution. Instead of, sensors are typically very expensive, and they might even do way more than you need them to do, but there are low-cost sensors out there. And the researchers use these low-cost sensors to monitor particulate matter. It's also called PM, but I'll continue to call it particulate matter, in 3 homes over a 2-week period. And surprisingly, all 3 homes had higher and more variable particulate matter levels than the outdoor environment. One home exceeded the WHO's 24-hour PM 2.5 rate. So basically, particulate matter 2.5 is basically telling you the size of the particulate matter. 2.5 is small, very small. And the WHO says over a 24-hour period, your particulate matter at the 2.5 size safety limit has to be a particular level, or else it could be damaging, right? So one of the houses of the 3 that they were testing, exceeded the safety limit. 9 of the 14 days, one of the houses exceeded this safety limit. And that's really concerning. So this shows that outdoor air quality, it's not a reliable indicator of what people actually breathe inside their homes. Indoor air pollution is actually influenced by a lot of factors, including household activities, the home ventilation system, and the external pollution sources around their home. So the study identified 5 key contributors, right? 2 related to the indoor activities like cooking on a gas stove, and actually indoor movement, meaning people move around in the house, and that has a negative effect on the air quality. And simply what it does is it stirs up settled particulate matter, which our houses are covered in, right? I mean, this stuff is everywhere. You ever have sunbeams come into your living space and you can see the air, you can see what's in the air, and you're like, damn.
As a kid, it's like, ooh, dust in the air,
Yeah, but that's, we're constantly shedding skin cells, and we're constantly adding pollutants to most of us are, to the air in our homes. So the other 3 I was talking about, these are linked to the external sources, and these would include emissions from, say, a nearby restaurant, right? That's not uncommon for a lot of people. So this variation definitely underscores the need for household-specific air quality monitoring. So why do particulate matter levels differ between homes? What's the reason why these 3 homes? They only studied 3 homes, and there was a big difference in them. Why is that the case? So the 3 homes in the study were located in the same neighborhood. It was Selly Oak, Birmingham, and they had similar structural features. This included gas and central heating, gas stoves, yet their particulate matter levels varied significantly. And it demonstrated how personal habits and ventilation and external pollutants impact the air quality. So these variations are affected by the frequency of cooking, and it's all cooking, but if you use a gas stove, it's a lot worse. And, what cleaning products are used. So outdoor pollution can get into the house right through your door, right through your windows. You ever feel a draft coming from a door in your house? That's because, the seal isn't 100%. That will definitely let outside air in. Your ventilation system will let outside air in. If you have a home, like a freestanding home, it is supposed to breathe. It is supposed to have an air exchange. You don't want it to be on 100% lockdown because the air, that keeps the moisture levels at in a place where you don't get mold and all that stuff. So larger particles, we'll call them particulate matter 10, right? They settle quickly because they're heavier, but the smaller particles, the 2.5 and the 1 tend to linger, and then this increases your inhalation exposure. Many people assume the indoors are safe, but they might actually be exposed to, worse pollution in their house. So what can we do about it? One of the study's key contributions was actually demonstrating how these low-cost sensors can track indoor air pollution. They can give you really good information. Researchers use something called non-negative matrix factorization. Say that, Bob.
Non-matrix factorization.
Fail.
Blah.
Anyway.
Non-negative matrix factorization.
Good job, Karen. This is a sophisticated data analysis technique that pinpoints pollution sources and the patterns of the pollution, right? And these sensors provide a very cost-effective way for homeowners and policymakers to monitor the air quality in real time. And you do want real-time monitoring. You don't want it to have to do a lot of processing. You don't want to have to actually send the data away, and have the results sent to you. You want to know what's going on day by day if you care to be that fastidious. Professor Francis Pope, who's a co-author of the study, said, "Our method is easily scalable due to its low cost and would allow air quality management in homes across Britain and beyond." He actually said that. So how can you improve indoor air quality? Like I said, first, you could buy some of these low-cost monitoring systems. There is no single solution. There's lots of steps that can help reduce exposure. You need to improve the ventilation, right? Open the windows if you can. When outdoor air is clean, and you could easily find that out on the web. You could use exhaust fans while cooking, right? You definitely want to have something sucking the air above your stove out and pushing it outside. Use air purifiers. I have one here in my office. You want something that has HEPA filters. You could get filters that can remove these 2.5 and the size 10 particles, obviously, because they're bigger. But you can get a HEPA filter that removes the small and more dangerous particles. You could reduce the indoor pollutants, right? Don't smoke inside. How about just don't smoke? Limit candles and incense, that they put a lot of stuff in the air. Use low VOC cleaning products, right? These are the harsh chemicals that we use. What happens when you use a cleaning product is like bleach or whatever, like any sprays and stuff, whatever is in there evaporates, goes right into your air. And again, monitor the air quality, get the low-cost sensors. You get the real-time data, which will allow you to monitor what's going on and make adjustments when you see something going on. Like if you're cooking and you see the air quality go down, that might tell you, hey, get a vent, or open the windows when the weather provides.
Jay, I had an air quality expert on Talk Nerdy years ago, and I remember talking to her about, the different contributors. She talked a lot about gas stoves and things like that, but she mentioned something that I don't know why it surprised me, I guess because I never really thought about it. She said one of the single worst things to have in your house without proper ventilation.
A pet?
No, a 3D printer.
Oh, wow.
Yeah, she said they put off so much toxic garbage that you should really put your 3D printer in a vent hood if you can.
Yeah, because the plastics that they use, they have to get hot enough to become malleable, and they're off gassing.
Yep.
So yeah, I could see that. Yeah, and there's places there are companies that have 100 3D printers cranking out stuff all day, all night.
I hope they have massive vent hoods ahead above them.
And, and still, I want to make a side comment because you brought it up, Kara. Mm-hmm. My mother-in-law bought my son a, one of those 3D pens, you can make objects. Oh my God, super fun, guys. Like a lot of fun. And you could really get creative. You could, there's a learning curve, definitely. Like I got better after I did it like 4 or 5 times. But you know what? I'm sitting there and I've got all this plastic, like leftover junk residue, mistakes, all that stuff. And I'm like, oh man, like, like there's a lot of plastic waste going on with this toy.
Yeah. It's too bad you can't melt it down and like reuse it.
Yeah, I don't know. Maybe there is like a waste, recycling type of job. But now I'm scared because if you heat it up, it's putting crap in the air. So
yeah, I might want to wear a mask while you're playing with it.
So my final thoughts here, guys. Go on Amazon. Search the web. Try to find some low cost sensors that can give you some real data on what's going on in your home, and then respond to what they tell you. If you have bad air quality, do something about it. Get some air filters and open the windows. Make sure you have ventilation, be careful about what products you're using. There's lots of things you could do that could have a significant improvement in your home.
All right. Thank you, Jay.
Right.
Kara, this is a difficult topic. What is the effect of the recent abortion bans in the U.S. on infant mortality rate?
What do you guys think?
Oof. It's bad. That's what I think.
Yeah, it's not going to be good, is it?
Well,
so researchers recently published a paper in JAMA called U.S. Abortion Bans and Infant Mortality. It was just published online on the 13th of February. So this was looking at the rate of death among children under the age of 1 before and after the abortion bans took effect. They looked across all 50 states, but they specifically compared states that had either implemented a total abortion ban or a 6-week restricted abortion ban, which for all intents and purposes is like a total abortion ban because very often people don't know that they're pregnant until that point. So they looked at Texas, Alabama, Arkansas, Georgia, Idaho, Kentucky, Louisiana, Mississippi, Missouri, Oklahoma, South Dakota, Tennessee, West Virginia, and Wisconsin, and compared the befores and the afters. All of those bans or near total bans were passed between September 2021 and August 2022 after the Dobbs decision. And they found that once the bans kicked in, 5.6% more infants died than would have if the bans were not imposed. Across their analysis, that was an extra 478 deaths. And let's dig into that a little bit more. Black babies were disproportionately affected, 11% increase in estimated child deaths compared with other racial and ethnic groups. Also, an 11% increase among children with congenital anomalies, so children with birth defects. The researchers posit that this is likely because that many women were, forced to carry fetuses to term that were never going to survive anyway. And so we saw a higher death rate among, babies born with birth defects. Digging even a little bit deeper, there are some questions here about whether this trend will continue or whether it will plateau at a certain point. There was an interesting comparison as well when we look at different states. So, for example, southern states had higher infant mortality rates than northern states with the bans. And the researchers argue that it's probably simply a function of geography. Like if you live in Alabama and you have an abortion ban, you're less likely to travel across state lines because it might require more money. You might have to fly or you have to put gas in your car multiple times. Whereas if you're in a northern state where there was a ban, you might be able to go just across the border. And so they think that actually affected the abortion number, which then affected the infant mortality rate. So researchers still don't know if this trend is going to hold. This is only infant mortality. We're only talking about between the time the babies are born and at 1 year old. What we're not looking at all with this data are women dying in childbirth, right? So we're not looking at the mortality of the mothers at all. We're only looking at, or even women dying during pregnancy or childbirth. So there is some research that does suggest that maternal death rates are also on the rise in places where there's restricted access to abortion care, which has face validity. But we do need more evidence to support that. Kind of bad news across the board, and the news gets even badder when we look at another article, which was originally published in an outlet called KFF Health News, but was republished by Undark, looking at the statewide publication of abortion statistics. And there's something kind of fishy going on here. So in Arkansas, in 2023, where there are 1.5 million women living, the published abortion statistic for the state was 0. In South Dakota, the published abortion statistic for the state was 0. And in Idaho, the published statistic was just 5. When they looked at kind of the same states that I mentioned earlier in the list for this other study, they found that many government officials across states with total or near total abortion bans started claiming 0 or a very, very low number of abortions starting in 2023, which was, of course, the first full year after Dobbs. And there are some, quotes. I think this is an important one that sort of summarizes the argument here. Amy Kelly, an OBGYN in Sioux Falls, South Dakota, said, "To say there are no abortions going on in South Dakota is ludicrous." She mentioned that many people have come to her hospital after taking abortion pills or to have medical procedures to help prevent death or end non-viable pregnancies. And she was like, I can think of 5 off the top of my head that I dealt with personally, and I have 15 partners just in this hospital. So there's a concern here. What is wrong when government official statistics are not in keeping with reality? Why is that a problem?
Because policy is based on those statistics.
Of course, right? That sets the standard for decision making for years and even decades beyond. So,
but what we're seeing is policy is dictating facts. Facts are not dictating policy.
Of course.
Right.
And that's really
that's authoritarian. It's 1984. That's what you do. It's double plus good, right?
And that is the claim here that is really, really disconcerting, is that we are not only seeing that, like you said, the policy is dictating the facts, not the other way around, but we're seeing a deep politicization of numbers, of pure evidence. These are not subjective statistics. These are objective statistics. And when they've become so politicized that, number one, individuals who are performing abortions are too afraid to document that for fear of retribution and very often prison time. And number two, people don't know what the guidance is because there's pressure, coming from different directions to say 0, even if it wasn't 0. What you end up with is this kind of culture of people going along with that claim. And then what happens later when we say, oh, in a state with no abortions, these were the statistics, these were the numbers, look at the maternal health, look at the, infant health. Well, that doesn't really tell us anything if there were actually 500 abortions that took place. It's very, very unlikely that across these states there were no abortions. We do know that some of these statistics are not based on pharmaceutical abortion because those happened across state lines, blah, blah, blah. But even with medical abortions, it's just highly unlikely. Abortions still happen even in these states when the mother is going to die, when specifically it has to happen to save the mother's life. And yet still these states are claiming that that happens 0 times. And it's just really not feasible. So, yeah, this is... I could probably find 50 more articles about some of the negative ramifications that happened after Dobbs, but these are pretty objective outcomes that are really disconcerting and really aren't political or shouldn't be politicized. They're nonpartisan outcomes.
And whatever your partisan view is, you have to acknowledge the reality.
Absolutely.
If this is the trade-off that you advocate, then advocate it. Don't pretend it's not a trade-off.
Yes, and that's what's happening now is that, let's cook the books, so to speak. Right. And that's a really dangerous thing to do when we're talking about public health. Mm-hmm. Yeah, and usually the CDC does collect statistics. Not every state contributes, but the CDC does collect statistics on this. Who knows if that's even going to continue? Kara,
don't worry. RFK Jr. is going to sort it all out.
Right, yeah.
Now we have totally fact-based American public health policy.
Sure. We could just get some ivermectin and we'll all be fine.
Yeah. It's all good. Just get that, once you remove fluoride from the water, it all will go away.
Yeah, then we'll be good.
Yeah. Okay, Bob, tell us how to make a black hole without a singularity.
What?
In 10 easy steps.
Yeah, just go in there, kick out the singularity, and you're good. Yeah, this was so much fun. A fascinating paper published recently has for the first time modeled a black hole without the need of a pesky singularity inside, and also without the need of some weird exotic matter to make that singularity disappear. These scientists are from the Institute of Cosmos Sciences of the University of Barcelona, and this was published in Physics Letters B. The title of the paper is Regular Black Holes from Pure Gravity. Pure gravity. All right, put on your seatbelts a little bit, guys. Let me just set the table quick, though, for this paper. And this should be nothing new for many of our listeners. Einstein's general relativity paints a picture of gravity as what? Space-time curving in response to mass and energy, right? Mm-hmm. Collapsing matter has nothing to stop it at the center of a black hole. It just keeps collapsing. The result is what Einstein's field equations describe as a point of infinite density and curvature that we call a gravitational singularity. If true, this wouldn't be just some abstract concept of infinity. It would be a part of the physical universe. And scientists are like, I don't think so. They've had a problem with this since the get-go. The main problem is that this is essentially a black box in these black holes. Our best theories that handle these extremes, like quantum mechanics and general relativity, can't make predictions about what's in that box by themselves. We need to combine them into one of the holy grails of physics, quantum gravity. We have some partial models of quantum gravity. I'm sure you've heard of some of these: string theory, loop quantum gravity, the holographic principle, and there's other ones that are more obscure, but none of them are really ready for prime time, obviously, or you would have been hearing me crow about that on this show over and over. In the meantime, to remove these singularities, scientists have often resorted to models that invoke what's called exotic matter. I hadn't followed this too closely. I wasn't aware of how this worked. But what they would typically do is they would take this exotic matter, usually takes the form of matter that has weird characteristics like negative energy, and they could have potentially weird counterintuitive effects on gravity. And the hopes is that that exotic matter could alter the collapse of the matter that forming the singularity. Alter that collapse, somehow preventing the formation of a singularity, maybe replacing it with some new quantum structure with finite density and curvature and no more infinities. That was the hope. Unfortunately, this exotic matter has never been observed in nature, and it's purely theoretical. So they're just kind of like, well, let's see what happens if we do this. Even as a theoretical construct, it's hard to use and work with exotic matter. But can you guess why it's hard? It's because we would need quantum gravity to understand exotic matter and what its possibilities are better. So it's just like, here we're back to this quantum gravity again. We don't have it. We need it. Okay. So then creating a model that does away with the need for a singularity without invoking exotic matter, that's pretty slick, right? So how do they do it? So I grabbed the bottom line quote from the paper, in my mind, the most important quote from the paper, and it was, "We show via an explicit construction how an infinite tower of higher curvature corrections generically leads to a resolution of the Schwarzschild singularity." Okay, an infinite tower of higher curvature corrections. Jay, repeat that to me. Gotcha, punk.
Infinite power, higher corrections.
No.
Forgot
wrong.
the curve part.
That's the meat of this whole paper. Infinite tower of higher curvature corrections. And I was when I read that, I'm like, what does that mean? Where are they going with that? How am I going to describe this? Another way to express that so that it's marginally easier to understand is it's just an infinite series of curvature corrections. All right, that's better. I know the word curvature in this context, right? That makes sense. But what is being corrected? And why do we need an infinite number of them? So what was going on there? So what they're doing is they're refining general relativity, because general relativity is real good in low energy regimes. If you want to deal with orbiting planets and bending starlight, then general relativity is fantastic. But when energies go really high, like as they are in a collapsing star, then general relativity needs to take that into account. Those high energies need to be taken into account. So that's why these quantum corrections need to be added to Einstein's equations. So it's a lot like Newtonian mechanics. Newtonian mechanics predictions at low energies and velocities are wonderful. If you want to put an orbiter, a probe into orbit around Pluto, then Newtonian mechanics can absolutely do that. No problem. Perfectly fine. No worries. But if you need to deal with anything that's near the speed of light, then Newtonian mechanics fails. It's not going to do what needs to be done. And this is one of the places where special relativity was able to step in and show it how it's done. So now to summarize that quickly, this paper supports the idea that general relativity is really the general relativity that we know, they contend, is really a low energy approximation. Higher energies need to be accounted for with these curvature corrections. So that's why these curvature corrections are needed to be added to take into account these higher energies involved. All right, so why do we need an infinite number of these corrections? And I found a good analogy for this, and the analogy is a stairway. Now imagine the shape of a stairway. The shape of each step you can think of as an abrupt jump in the curvature, like a singularity, right? Do you follow that bit right there?
Mm-hmm.
You know, if you're following the pathway up and you got the step, that peak, that shape is kind of like a jump in curvature. Now you could smooth that out by adding curvature corrections. Now in this analogy, you could replace each one, but replace them with a smaller step. And then you do it again. Replace all the steps with smaller and ever smaller steps. So now if you want a perfectly smooth ramp, you would need an infinite amount of smaller and smaller steps.
That makes sense.
Now I know that's not a perfect analogy, but I hope it kind of gives you the idea of what was going on here and why they need an infinite number of these in order to make these corrections. So this is how you can get rid of a black hole singularity in this paper. This is kind of how they describe what's happening. Now, you make these quantum corrections to Einstein's equations to account for the high energies involved. Now, a finite number of corrections will help. It will lessen the infinite curvature of the singularity, but it will only lessen it a certain amount. You need an infinite number of these corrections, and when you do that, then the singularity will disappear. So this is why that quote from the paper that was referring to the infinite tower of higher curvature corrections, that's why that quote was so important. It really encapsulates the whole thing. What this theory is doing essentially is describing a deeper, more generalized version of general relativity. That's an interesting point, a very important point to get across there. So why is this compelling? One of the thoughts I had was, why is this compelling to scientists? And why, couldn't this just be some ad hoc lucky fix, with no likely relation to reality? And that was, so I had to do some digging to find out, why is this compelling to these scientists? Why could this potentially be a really important paper? First of all, the techniques that they use these infinite series to refine low energy approximations, that is common. QED, quantum electrodynamics, did it for Maxwell's revolutionary equations on electromagnetism. This is something that has been done in physics and in science over and over. This is not just something that, hey, let's throw an infinite series of corrections in here. This is something that's been done before. Also, they looked at other quantum gravity models like string theory and loop quantum gravity, and those models already predict that general relativity needs an infinite series of corrections at high energies. They already said this. So when you have multiple independent quantum gravity frameworks agreeing on the same type of corrections, that at the very least should be very encouraging to your theory, I would think. And then another reason that this is compelling is that they found that these quantum corrected black holes, this whole theory complies with the first law of thermodynamics. So that's always a sweet consistency check. If you're breaking the first law of thermodynamics, maybe you shouldn't publish that paper until you figured out what was going on. So in conclusion, I was thinking, so what would be a good follow-up at this point? And I was thinking, well, what's there? If there's no black hole singularities, if they are just an artifact of a low energy approximation of general relativity, then what's there? What are we going to find there if we can find out what's in there theoretically or even experimentally? One idea is that inside a black hole could be a theoretical Planck star, which I hadn't heard too much about. Planck star, it's an uber dense quantum object, right? That makes a lot of sense. Extremely dense, but not infinitely dense, which is, of course, what we're actually going after. So a very, very dense quantum object, and it might have bizarre properties, like it could exist in a superposition of multiple distinct states. Who knows what that thing could be like, if it even exists. They talk about quantum effects that could cause a slow a slow time-dilated rebound. Some people say that there could be bizarre quantum effects inside these black holes that actually allow for a rebound, but this rebound is slowed down because of the intense time dilation. And they say it could potentially become a white hole in many billions and billions of years. That was pretty fascinating. On the other hand, some people say that the interior of these quantum-corrected black holes have been described as potentially fuzzy, fluctuating quantum space-time with a weird, complex quantum structure. Who knows what the hell's in there? This is what some quantum gravity models point to these potentialities. And I'll end with the coolest part of all, is we may be able to actually find out about this experimentally, observationally, when these black holes merge. You know how we've detected gravitational waves of fluctuations of space-time traveling at the speed of light away from these massive events like merging black holes. Those waves may have some nuanced differences to what general relativity in its low-energy approximation predicts. We might be able to detect the gravitational waves from colliding quantum-corrected black holes that point to the fact that, yes, these black holes do not have a singularity. They have some sort of something else that's not infinite density and infinite curvature. So there you go.
Bob, can you state a concise takeaway from this?
Yes. The very annoying gravitational singularities in black holes might not exist because they might just be an artifact that doesn't exist in reality because general relativity, as it's laid out now, is just a low-energy approximation.
All right, that helps. Well, everyone, we're going to take a quick break from our show to talk about our sponsor this week, Quince.
Here at the SGU, we love Quince because you can find high-quality items at not high-quality prices, like 100% Mongolian cashmere sweaters from only $50. There are like washable silk tops and dresses and even 14-karat gold jewelry. And the way that they do this, the way that they keep those prices down, we're talking 50 to 80% less than similar brands, is by partnering with top factories. They cut out the middleman and they pass the savings straight on to us. And I love this. They only work with factories that use safe, ethical, and responsible manufacturing practices.
I just bought my wife one of the coats on the Quince website. Bottom line is everything that I've purchased from them for me and my wife is awesome, like high quality. I really do think their stuff will last a really long time. I love it.
Give yourself the luxury you deserve with Quince. Go to quince.com/SGU for free shipping on your order and 365-day returns. That's QUINCE.com/SGU to get free shipping and 365-day returns. Quince.com/SGU.
All right, guys, let's get back to the show. Evan, finally, we're going to ban something that doesn't exist.
Leprechauns? Unicorns?
Chemtrails. What's going on?
Yeah. Chemtrails theory. Oh my gosh. That is a fantastical suggestion that governments or other secret powerful organizations are deliberately releasing chemicals into the atmosphere through airplane contrails. And they're doing so for sinister purposes like weather control, population control, and mind control. It's all about control with them. Chemtrails theory, in every respect, is actually a conspiracy theory. Yep. All right. I mentioned contrails. Contrails, that's short for condensation trails. Those are those white streaks we all see behind the airplanes. They form when hot exhaust gases from jet engines mix with the cold air at those high altitudes, and it causes water vapor to condense and form ice crystals. Simple enough. But there seems to be a prevailing understanding that contrails will dissipate in a relatively, short amount of time. 30 seconds, maybe a minute, 2 minutes at most, and, they're gone. However, if a contrail seems to hang around for, 5 minutes, or 10 minutes, sometimes 60 minutes, after that plane formed the vapor trail, well, something must be amiss, right? I mean, contrails hanging in our sky for an hour, that shouldn't happen. Because we all know how long water vapor and ice crystals should last at varying altitudes and temperatures and air pressures. We're all meteorologists here. No. There's something else mixed in with the water vapor and the ice crystals, right? Something deliberately added by people, because what better way to get insidious and harmful chemicals to fall from the sky and ultimately wind up becoming part of the air we breathe and in our homes, Jay?
Because why?
That's right.
Because mind control?
Yes, it's all about the mind control. Okay. Mind control, population control, weather control, it's all control. Yep. Oh, these are clever minds at work, and they're sinister minds. Super secret, top-level government-led population engineering attacking the air we breathe. What is this all about? The understanding about why not all contrails are the same come down to rather basic understandings about what? Temperature and humidity. So if the humidity is low and the temperature is not cold enough, and cold enough meaning 40 degrees Fahrenheit, I'm going to use the Fahrenheit scale for this, then contrails, yes, they will dissipate relatively quickly, a minute, 2 minutes at most. However, if the air is moist and the temperature is below 40 degrees Fahrenheit, well, that contrail will persist longer, much longer in some cases, 60 minutes or more in several circumstances. So yeah, if the air is cold and humid enough, these tiny droplets freeze almost instantly into ice crystals, and there you go. You got your contrails. But the chemtrail conspiracy theory, this dates back, many decades. There are some reports of this kind of shenanigans dating back almost 100 years. I mean, that's practically the history of flight, of modern flight. But it's been investigated. It's been investigated by scientists. Qualified investigators have taken a close look at the claims over all this time of that supposed evidence suggesting that chemtrails are real. And in every instance, it turned out to be what? Bad evidence. They either collected bad data, or there was bad interpretation of the data, or there were misidentifications of things all over the place. And that's not even to mention the hoaxes, faked videos, and pictures also presented as legitimate evidence. So, as usual, there is zero scientific evidence to support their claims, and therefore chemtrails are nothing more than vapor trails and ice crystals caused by the exhaust of jets. They are contrails, nothing more. But here we are, 2025, the age of AI, advanced robotics, and other scientific wonders that shape our modern society. And what are some of our state governments here in the United States doing with their valuable time and resources? Uh-oh. They are working on legislation to ban chemtrails. Oh, gosh. But Evan, how can they ban something that doesn't exist? As Steve brought up. Well, that's a great question, Evan. They can do it because despite this amazing modern society built on scientific literacy, some people cannot overcome their, as I call it, reality-challenged existence. And those energies are used to lobby legislatures to also do stupid things. Remember, politics is downstream of culture. And in this example, culture are the airplanes and politics are the contrails. And in recent weeks, there have been multiple state governments, not just one, multiple state governments that have been working on legislation to curb or ban or investigate contrails in the belief that they are actually chemtrails. I'll give you a couple of examples. Iowa, local CBS affiliate in Des Moines, says 23 House Republicans have signed on to an anti-chemtrails bill in Iowa, despite not having any hard evidence that it's actually happening. The bill states it would ban the intentional emission of air contaminants into the atmosphere with the intent of changing the weather. And here's a quote from Representative last name Grassley, so I don't have their first name. Some would say, well, it just isn't happening. Others would say it is happening. I think it's something we need to have a discussion about as a legislature. So they're doing it in Iowa. What are they doing in Florida? According to the Palm Beach Post, Florida politicians indulge conspiracy theorists with nonsense chemtrail bill. Conspiracy theorists who imagine that some vague amorphous operatives in the federal government are intentionally trying to poison the country by trailing clouds of toxic substances. And one of the leading voices of disinformation on chemtrails is, who's this? Robert F. Kennedy Jr.? Do we know that? Yeah, U.S. Secretary of Health and Human Services, who claims, this was just last August of 24, says we are going to stop these crimes. Chemtrails are apparently crimes, according to Robert Kennedy. These things don't exist. And these kinds of things got stirred up even more in the recent events that took place in places like Florida with the hurricanes and North Carolina as well, in which people believe that this is actually happening. And some of this stuff was the result of chemtrails, chemicals being added into the atmosphere. California, Shasta County, concerns about chemtrails, drone surveillance, and election fraud, among other things. But during a marathon 9-hour meeting that last week, Shasta County supervisors deliberated over who to appoint to the county commissioner boards, but an hour of that meeting was dedicated to the perceived dangers of chemtrails. They received a presentation on the alleged dangers of chemtrails from a local community member who had no scientific or official credentials. However, they run a website called Geoengineering. Name is Dane Wigginton. Geoengineering Watch is the name of his organization. And he produced a documentary. So therefore, he was called up to have his say. And he says, obviously this is happening and I have the evidence. But there are others who have looked into his claims and said it is 100% fantasy. And finally, I'll bring up Arizona. Arizona this week, according to the Arizona Mirror, chemtrail believers are swaying GOP lawmakers to support geoengineering ban. House committee passes a bill that would outlaw cloud seeding and climate intervention research after supporters cite debunked conspiracy theories about chemtrails. This bill will ban geoengineering, citing the long-debunked chemtrail conspiracy theory as evidence that nefarious actors are already turning Arizona skies into a laboratory and treating its unsuspecting residents as guinea pigs. And that's just 4 examples. My understanding is that there are as many as 20 or more states who are either going to at some point this year or have already begun the discussions about chemtrails in their legislatures. This is an enormous waste of time and resources. It is absolutely pure fiction and pseudoscience, and just one of the many things, once again, we are wasting valuable resources.
It's so telling of where the state of the politicians and regular people out there, like the misinformation has seeped in very deep into a lot of people.
Yep, politics is downstream of culture. Yep. That's right.
And there's no way to really pull them out. Like I'm sitting here thinking, like, well, what could we do? We could communicate that it's false, but people, like that's it. Anything that they hear to the contrary is the conspiracy at this point.
Yeah, absolutely, and it's not like there hasn't been decades and decades of research into this very thing. And once again, it's on a par with UFOs. It's kind of like that. What the federal efforts are to deal with UFOs and those things and whatever resources are being pumped into that, the same thing is happening now with chemtrails at the state level, at least. And who knows, maybe someday at the federal level, this will also happen. And who knows, Robert F. Kennedy, among other people, making these kinds of suggestions, who knows how big and more, prevalent this is going to become. And, just pseudoscience and absolute fantasy fiction.
But operationally, Ev, it's like, okay, yeah, let's ban chemtrails. Go for it. What do you do?
I know. What does that even look like?
You're right. It's like banning ghosts, right? But, it speaks to the culture. It speaks to kind of where we are in certain collective circles. And it's just not good. And this is just one more example of that.
All right. Thank you, Evan. All right, Jay, it's Who's That Noisy time.
All right, guys, last week I played This Noisy.
Pakistan Today we have to the border in Afghanistan we near after the Afghani OCC border area. We have to the rocket launcher firing after in the people 3,500 of Boston.
What do you guys think?
It sounds like fake English.
Yeah, it's like that song that George does at the extravaganza where someone just makes up a bunch of English-sounding words, but they're not words.
Cute soul.
All right, good. That's actually, you guys are in the right place. So a listener named Stephen Walker wrote in and said, "Hey, Jay, my guess for this week's Noisy is a recording from a ghost box or spirit box. I had to look up what they were called, but I had a hazy recollection, probably from an earlier SGU episode, that so-called ghost hunters would use these devices that hopped about different radio frequencies and recorded snippets of each to reveal secret messages." Yeah, so I think that's a good guess. I mean, because this is a very gibberish sounding thing that's happening. And if, you were able to switch between radio stations very quickly, it would have a gibberish sound to it as well. But this is definitely not that. I have another listener named Michael Blaney who wrote in and said, "Hi, Jay. Am I having a stroke or something? It sounded almost like English, and I definitely caught a few words here and there. So I guess it's an AI-generated speech with a prompt, something along the lines of give a newscast in a World War I style report." Yeah, I see that. And that is actually a very good guess because, what else but AI would be able to produce something like that if it's not real. And a lot of people out there know what this is because I got a ton of emails. Apparently this dropped on the internet, I guess, a couple of weeks ago. The listener named Shane Hillier wrote in. He was the first person to guess. And he said, it's an Afghani dude pretending to speak English. And that's exactly what it is.
Yeah.
This comes from a video.
Oh, boy.
Basically, they're making fun of what English sounds like. They could listen again and tell me what you think.
Eyes up, Pakistan Patan. Today we have here the bordering of Afghanistan near after the Afghani OCC border area. We have to the rocket launcher firing after the people 3,500.
I think he does a great job.
I think it sounds pretty good.
Yeah.
It's
I think
fantastic.
This is good.
I wonder what, during the extravaganza, George has a bit where he pretends to speak in other languages, like German, but it's fake German. But to us, it sounds like German. But I wonder what it would sound like to a German speaker, to a native German speaker.
Probably just like that.
Yeah, right.
Babbling.
Yeah, it's the phonemes or the phonemes.
The phonemes.
The pheromones. Anyway,
Phenomenal phonemes.
I absolutely love this one. It tickles me to hear him do such a good job. And he's putting on like he's got like that deeper cadence thing going on too.
And you pick up a couple of words in there, which is I'm sure totally accidental. Like I thought he said 35 at some point, but that's just audio pareidolia.
I don't know. I would imagine just like with us pretending to speak other languages that we do throw some legitimate words in there.
Maybe, yeah.
But who knows? Anyway, thank you so much for sending that in. That was great. I have a new noisy this week. This was sent in by a listener named Gertie. Gertie, you know who you are, and thank you so much for this. It's a lot of fun. Let me play this for you guys. All right.
Interesting.
Guys, if you think you know what this week's noisy is, or you heard something cool, email me at wtn@theskepticsguide.org. Steve, we have Nauticon coming up.
Mm-hmm.
And we hit another milestone with Nauticon because we have completely finished our programming and basically all the details for those shows. So we're in really good shape. We had a big meeting last night. We have a lot of fun when we talk about this stuff. We had a big heated debate. I'll tell you what it was about at the conference, but we had a really big and funny heated debate last night.
I was right, by the way.
Yeah, Steve thinks he's right. Everybody else doesn't agree, but that's typical here at the SGU.
No,
so
I got multiple people to agree with me.
There was a spectrum of feedback.
Yeah, there was. But that's what they're saying to your face. But anyway, I've a few reminders for those of you listening to the show. As you know, Steve is coming to the SGU to work full time. If you guys want to help support that effort, I mean, the goal here is that we're in process of creating four new different shows, all of which are, in the hopes of pushing more good science content and skeptical content out there. They're very different programs, and we're very excited about all of it. It's going to take a lot of time and money to pull it off, and we could really use your support now more than ever. And let's face it, guys, I mean, we all know things are very, very much different in the world today than they were 20 years ago when we started this podcast. We need to push out these messages. It needs to get out there, and that's why we're doing it. Essentially, that's why we've made plans. Steve could have just retired and done the podcast, but he tripled down and said, "No, I got, if anything, we've got to increase our output." So that's what the plan is. Please join us with that. If you become a patron, there is a lot of content on there that is not available anywhere else. We do special shows that are patron only, or patrons get early admission or whatever. There's lots of things that we try to do for the patrons. But the bottom line is, we know that your support is being offered to help us do what we do, and we want to do more of it. So please consider becoming a patron. You can go to patreon.com/Skeptics Guide. We have a mailing list. You can go to our website to join that mailing list. It's going strong. Every week we drop an email that talks about everything that we did the previous week. Thank you, Steve.
Thank you, Jay. We're going to do one email. This email comes from Stefan Magnuson, and he writes, I was reading up on Asteroid 2024 YR4, and I came across this on its Wikipedia page, and then in quotes, calculations using the observation arc of 55 days as of 18 February 2025 find that 2024 YR4 has a 1 in 32, or 3.1% chance of impacting Earth on 22 December 2032, around 1402 UT, and a smaller possibility of impacting the moon about an hour later. I know you've talked about this asteroid before and potential consequences if it were to hit Earth. Not great, not terrible. Given the time frame, there would at least be some opportunity to evacuate affected areas. But what about the moon? Since the moon is much smaller, could a direct hit pose a greater risk of destabilizing Earth's tides, for example? Is this something to be concerned about? And what kind of consequences might we expect if it actually happens? I'd love to hear your thoughts on this, and thanks for all the skeptical work you do.
But bottom line, not a concern.
Not a concern. Yeah, you're jumping ahead a little bit.
It could actually be quite wonderful in a lot of ways.
I agree.
But
we'd learn a lot.
So based on some research I did about this, this could create a crater on the moon that's up to 1.2 miles wide, 2 kilometers. So it seems big, but that's really just a pothole compared to some of the big boy craters on the moon. There's one that's 1,500 miles wide, 2,400 kilometers in diameter. So this would really be just a blip. In terms of the tides would have no impact.
There is no asteroid in our solar system big enough to affect the moon's orbit or to crack it open, right, is the bottom line.
All that debris cleared out a long time ago.
In fact, if you collected all the asteroids in our solar system together, they would have less mass than the moon. Less than the moon. Every single.
Wow, that's even less than I would have guessed. But that's interesting. The other angle here is that, well, what if some of this debris from the moon hit the Earth? And that's possible. Chances are, though, that the small rocks would just burn up in the atmosphere, and we could potentially, if this happened, get a striking meteor shower, which could be a lot of fun.
Yeah, Bob, imagine if it smacks into the moon, we get a great show, and followed by the best asteroid shower meteor shower we've ever seen.
Sign me up.
Oh man, watching that happen, that would make my astronomical day right there. Oh, well, it'll be more than a day because it would take a while for that stuff.
So there is a bit of an update though. So he was giving the numbers for yesterday as we were recording the show.
3.2%, right?
3.1%, but NASA updated their numbers based upon overnight observations because we're getting better observations now because the full moon's no longer in the way
Thank
of
goodness.
observing it.
What's it up to now?
It's actually went down. It's down to 1.5%.
Oh,
whoa!
But
so much for that.
Still, it's over.
I didn't see
over
that.
1%, but they downgraded it from 3.1 to 1.5%. Still at 3.1%, that was the highest probability
ever
of any asteroid this size hitting the Earth, this size or bigger. The probability of hitting the moon is 0.8%, so just below 1%. That's still relatively high as these sort of things go. But it's 0.8%, so we could hope for that. Hope for a moon impact. That'll be cool. But it's not going to affect its orbit, not going to affect our tides, nothing.
I wouldn't mind a little bit of a scare, though, to get us off our asses. I mean, I know we've been pretty good about tracking near-Earth asteroids, near-Earth objects, and that's great. But, I think a little extra effort, I think, could be worth it. And to actually be prepared, to actually have some sort of rocket ready to go would be kind of nice. But I also read that if it hit the moon and some of the rocks from the moon actually hit the Earth, if they were big enough not to burn up in the atmosphere, even they would be very small, and they would actually be you'll probably see them on eBay. If somebody grabbed them, they would be that would
valuable.
Be very scientifically valuable, as you could imagine. So yeah, don't worry about the moon or the tides. But hey, man, who knows? It still could hit. We will know probably even more definitively in a month. I heard that in a month, the James Webb Space Telescope will be taking a look. And I don't know why it's taken a month to do it. I'm sure it's got a very busy schedule. But that might be our last good look at that object until 2028.
One other thing, if it hits the moon, that takes it out of contention for hitting the Earth ever, right? We don't have to worry about it coming back around whenever and crossing the Earth's path.
Yeah, that'd be fine.
One less object.
Yeah, one less object to worry about. Jay, you're going to give us an entry of Swindler's List.
Oh. I am. Well, it's tax season here again in the United States.
It is.
Wabbit season.
But this applies to basically any tax season anywhere around the world because, there are scams going on that impact people filing taxes and so anything that has to do with your personal information, that this could apply. But in the United States, we have taxes coming up, And I have a list here of 6 different things that you got to keep your eye out for. So there's something called IRS impersonation scams, right? We have scammers that pretend to be IRS officials, which is bad because there's a lot of people out there that really wouldn't be able to discern the difference between a person from the IRS calling you or not. Now, the fact is they won't call you, and they basically don't call you. They don't contact you that way.
Correct. Not unless you are already engaged in a case with them.
Right.
That would be the only exception to that rule.
Yeah, and that's fine because, you already know people and you have names and all that stuff.
And that would have happened in writing, probably through a series of documents among, not just one letter. So, yeah, you would have to be pretty involved at that point with that particular case for calls to happen.
So what these scammers will do is they'll call up pretending to be from the IRS, and they'll claim that you owe taxes, and then they'll threaten arrest and deportation, whatever, anything that they can do to get you to pay immediately. And guess what? You're not paying the IRS, you're paying them. And they could ask for a ton of money, and people that don't know the difference could end up losing all the money that they saved to pay their taxes. Very, very bad situation. There's also something called tax preparer fraud. In this scam, you have a fraudulent tax preparer, right? Someone that will help you prepare and file your taxes. And what they'll end up doing is that, one of the things that they'll pull on you is they'll promise you very large refunds. And I know how to get the most refunds and all that stuff. And it's common for them to falsify information on your returns. This would end up leading the person who falls for this scam into having big penalties as the taxpayer. And of course, they can always steal your personal information and use it for identity theft, which is a whole other freaking mess that you don't want to get into. The phishing scams are the ones that I think most of us would interact with. Now, these are essentially fake emails, right? They'll send you email. It'll have fake websites on it that look exactly like official IRS websites, and whatever, the emails that the IRS sends out, all they got to do is get their hands on one of them and essentially copy the format. And what they're trying to do here is get you to give them your personal information, or download malware, which would even be worse because, then they can really get all your information. The IRS is never going to initiate a contact via email. So just be careful. You got to know what channels the IRS would contact you through.
Yep. Or text. They will not text you either.
Then we have the Social Security number scam. Scammers might claim that your Social Security number is suspended or due to tax reasons, right? And they're aiming to scare people into revealing their personal information. Pay money to reactivate whatever it is. Depending on who they get on the phone, they'll follow a script that they think would make the person most vulnerable, and watch out for that. Be careful. There are also refund scams. Scammers can file fraudulent tax returns using your stolen personal information, and they're filing your tax return, and they're trying to get your refunds. And this happens, guys.
Mm-hmm.
That happened to me.
Yeah.
But the IRS caught it, and now I get a PIN that I have to use to submit my taxes.
Which is good. And I think that will be the way of the future. It's a way of doing like a 2-step authentication and with the PIN.
Now victims, well, yeah, but they're laying off a lot of people that work for the IRS, so that's probably pushed out. People who fall for this, they find out about it when they submit their tax return and it gets rejected because it's already been submitted.
Right.
If this happens to you, contact the IRS immediately. You're going to need them to help you fix this mess. And then finally, we have something called ghost tax preparers. And these are people who, they'll prepare your taxes and then they'll refuse to sign the tax returns, which they have to do.
Yep.
It's basically illegal for them not to do it.
Correct.
And they'll also might promise large refunds and charge fees and on the refund amount. And they're often filing false returns. It's just a big mess. To protect yourself, you should always verify any communication that's claiming to be from the IRS and use, a reputable registered tax preparers. You gotta find the legit people out there. There's a lot of them. You can go on Google reviews. You can use a tax service like, the several electronic ones that are out there where you just go through a series of questions on a website that can help you walk through it. If you really want to work with the person, though, just do your research. If anybody calls you about anything to do with your taxes or you get any communication about your taxes of any kind, be super suspicious. Don't click links. Don't rush into anything. If the IRS really was reaching out to you, or if someone claims to be from the IRS and they do reach out to you, just say, okay, I'm going to call back an official IRS number and go through that channel. Don't let them give you a phone number. you get your own phone number off the web and make sure you have, you're on the .gov site. Check the spelling of the website that you're at. Be careful out there, guys. Scams are going to explode right in front of our eyes in now and forever, because AI is going to enable people to have more density with their scams and also, do a better job, to be honest with you. So just keep your eyes open and be smart about what you do.
And I would like to add one thing to that, please. Elderly people are more victimized by this than anyone else for a lot of reasons. So help out your family, your neighbors, if they need in these matters, because some people who are elderly don't always have somebody looking out for them, and they're left to their own devices to do it, and they're not sophisticated enough to understand these kinds of scams. So talk to your parents, talk to your grandparents, make sure everything's okay with them when it comes to their tax returns as well.
Mm-hmm. All right. Thank you, Jay. Guys, it's time for science or fiction.
It's time for science or fiction.
Each week I come up with 3 science news items or facts, 2 real and 1 fake, and then I challenge my panel of skeptics to tell me which one is the fake. We have a theme this week. The theme is GMOs.
Yeah.
Some info on genetically modified organisms. You ready?
Mm-hmm.
All right, here we go. According to the USDA, 55% of U.S. cropland grows genetically modified crops, while worldwide the figure is 13.4%. All right, number 2, although frequently a target of anti-GMO efforts, there is currently no GMO wheat variety on the market. And item number 3, scientists have developed a scorpion cabbage that produces scorpion venom in its leaves, but this has yet to gain approval in any country. Evan, go first.
Okay, number 1, 55% of U.S. cropland grows genetically modified crops. Worldwide, though, it's 13.4%. Okay, which means that, so the 55% for the U.S. is cooked into that worldwide 13.4%.
Yes.
Which basically, if you took the U.S. out of it, that figure would be much lower. We've talked about how I think these are illegal in some countries.
Well, define genetically modified crops, right? That's kind of important.
You mean like the general definition, right?
Yeah, meaning you mean it actually,
transgenic.
It is a. It doesn't have to be transgenic, but it meets the definition, the legal definition of a genetically modified organism that needs approval.
Perhaps the only thing that could be fiction here is this is a USDA survey of information, and how do they know really about what else is happening?
Let me clarify. The first number comes from the USDA. The second number does not come from the USDA.
Oh, okay. Thank you. I'm
comma,
inclined to think.
I know it's ambiguous, but I just got the figure from somewhere else. But yeah, don't hang your head on that, because that second figure did not come from the USDA.
Though I'm alarmed, because when you take the U.S. percentage out of this, that 13.4 really drops, and that's, in a way, a disconcerting number as it goes lower, because for so many reasons we've talked about, I have a feeling this one feels like it's science to me. The second one, no GMO wheat variety on the market. I don't know about that. That one's, straightforward. There's not really much information there to glean. It either is or it isn't the case. So, that one's almost a coin flip on itself. And then this last one, scorpion cabbage, never heard of it. Produces scorpion venom in its leaves. Why? To protect the plant. That way bugs and other mites and other things don't get in there. Has yet to get approval in any country. Okay, I believe that they've developed it, and probably 12 other things that are sound equally scary and crazy in a way. So I think the most likely one to be fiction will be the wheat one. I'll say that one's fiction.
Okay, Kara.
It's funny because, I agree with 55% of cropland, although that actually sounds low to me because so many of our staple crops are GM in this country, but 13.4% globally. Okay, yeah, that also feels low, but it could be accurate. But then I was realizing maybe the reason it sounds low to me is because we don't have GM wheat. Like, yes, I know that we have GM, like the big staple crops like soybeans and cotton and corn is a really, really big one. And we have some of those other crops like papaya, alfalfa, which is, animal feed. But then I was like, oh, maybe we don't have GM wheat because the scorpion cabbage is bizarre. This feels like, quote, frankenfood. It feels like a scare tactic that's often used. Like, oh, they're putting, genes from a evil, scary thing into this.
Fishmado.
Yeah, fishmado. So it's scorpion cabbage. So I don't know. That one feels like the fiction to me. So I'm going to not go with Evan this time and say that's the fiction.
That's okay.
You're saying the scorpion cabbage is
Yeah.
okay.
We're still friends, right?
Yes.
Okay.
Oh, thank goodness.
Jay?
Yeah, these are interesting. I mean, I'm going to jump right to the second one here. You're saying that although frequently a target of anti-GMO efforts, there is currently no GMO wheat variety on the market. So on what market, Steve?
Anywhere.
Okay. The first one about the USDA saying that 55% of U.S. croplands grows some form of genetically modified crops. Yeah, I mean, I think that's science because there's some really heavy hitter crops that have been genetically modified, and I think a lot of people don't even know about it. But that one is definitely science. The scorpion cabbage, I'm definitely with Evan. I don't know anything about this. It's producing scorpion venom in its leaves, and what the hell would they do with that? But I mean, it seems to me like that's doable because of our ability to genetically modify things. I mean, why couldn't they do it? But again, I don't know much about it. But I mean, my gut is telling me that there are wheat GMO crops. So this is saying there aren't, and I think that there absolutely is. So I'm going to say that one is science fiction. That's the fiction.
Science fiction.
Science fiction. Oh, that's a
science
good worker.
or fiction, Jay.
Oh, that was a good
I got it.
workaround, Jay. Clever.
All right, Bob.
Nice try, Jay. Damn, this one's rough. For some reason, I got stuck in my head that there is no GMO wheat.
Yeah, Bob.
So I could be wrong. I could be wrong, but for some reason, that's shouting in my head. So based on that, then I go to the third one. Scorpion cabbage, that's a lure right there. That's just like, yeah, they're not going to buy that. So for that reason, I'm going to meta here. Of course, I'm going to say that one is science because it's just so gaudily stupid.
That's bold.
So that means that the first one, 55% U.S. cropland grows genetically modified crops. That I don't know. These numbers I think have been tweaked up to a certain extent. I mean, 55%. So I was actually like, oh, if that's true, that's actually seems like a high number, especially when you add in the fact that about wheat not being GMO for some reason. So so I'm just going to like whatever. I'll say number one, the 55% cropland in U.S. Is fiction.
All right, so we're all spread out. I always love that. So how should we go?
Yeah.
Yeah.
You didn't get sweep, that's why.
So I guess I'll
start with two.
Guess
I'll get it over with. I want to rip the Band-Aid
I'll take them in order, which is usually what I do if you're all spread out, not to bias it any one way. According to the USDA, 55% of U.S. cropland grows genetically modified crops, while worldwide the figure is 13.4%. Bob, you think that one is the fiction. Everyone else thinks this one is science. And this one is science. Sorry, Bob. Yeah, so America has the high croplands that are GMO. There are some smaller countries that don't have nearly the market we do that have a higher percentage, but don't produce as much GMOs as we do. So the U.S. produces more GMO crops, I should say, than any other country, right?
Yeah, like in absolute quantity.
In absolute quantity, yeah. And for certain individual crops, so here's a breakdown of some of the crops. For sugar beets, 100%. That's it, just 100%. No one's planting non-GMO sugar beets. Canola is recently also hit 100%.
Oh, wow.
If for corn, soybeans, and cotton combined, it's around 94%. Alfalfa has been coming up recently. That's up to 20%. But for all cropland, it's about 55%.
Wow.
Let's go right to the second one, because that kind of bears on the first one. Although frequently a target of anti-GMO efforts, there is currently no GMO wheat variety on the market. Evan and Jay, you think this one is the fiction. Bob and Kara think this one is science. And this one is the fiction. Good job, guys. because
I can hear you saying, Steve.
Yeah.
I can hear you saying that.
I did say it recently.
This was all chaff. This was all chaff.
So I wasn't wrong.
So,
all right,
Steve,
good.
you want to know why I know about this?
Why?
Because you said it recently.
Because I bake bread and I do reading about wheat, and I was curious about it. And I guess it's where they make it in Africa or something?
No, South America.
South America?
So it's HB4 wheat, Triticum aestivum.
Quadrotriticale?
Yeah,
So there's actually
same
two.
thing.
There's two types of genetically modified. Yeah, triticum. There's HB4 wheat and there's Roundup Ready wheat. The HB4 wheat is drought tolerant, and that is being planted in some countries in South America who need the drought tolerance. But we don't really need it in the USA, so it hasn't really caught on. And I don't know why we're not using the Roundup Ready wheat in the US. I don't know if that's a marketing thing or whatever, what the logistics behind that. But yeah, so in the US, there's no GMO wheat in the US, right? Which is what I meant. But yeah, that's not true in the world. So
that's tricky.
There's GMO. That's why when Jay asked, "What do you mean? Which market?" I'm like, all of them. You know, I didn't clarify.
Right question, Jay.
I did not clarify. Therefore, it's the world market. But anyway, yeah, a little tricky. Which means that scientists have developed a scorpion cabbage that produces scorpion venom in its leaves, but it has yet to gain approval in any country. Is science.
The hell?
So yeah, Evan, the scorpion venom is a anti-pesticide, right? It's a pesticide, mainly targeting caterpillars, right? Because they eat cabbage. But the venom itself was genetically modified to not affect human cells. So,
there you go.
Yeah, so it kills insects, but it has no negative effect on humans. So this exists. It just hasn't gained regulatory approval in any country yet. I don't know if it's being held up for political reasons or if it just hasn't gone through all of the red tape yet. You know, it takes a long time to get approval. So it's just sort of stuck in limbo. But it may never come to market is the other thing from what I've been reading, and for unclear reasons. But that is an approach. You know, they're looking for, because we have like BT and the HT are like the two pesticide crops, right? So the BT produces a pesticide in the plant, so you don't have to spray it. And that, like, I think pretty much 100% of cotton is now BT cotton. It's just so much better as a commercial crop than non-BT cotton. It's completely dominated the market. So, which goes to show you that when farmers are left to their own devices, right? Farmers have now had 20 years, 30, almost 30 years to decide if they want to plant GMO plants or not. They're choosing the GMO varieties that are good for their business, right? That have less loss to pests, or have better yield, or lower inputs, or whatever it is. Those crops are thriving, except where they're banned, right? Except where regulation gets in the way because of unscientific reasons.
Remember Sri Lanka?
Yes, that was the one that banned artificial fertilizer. Is that what you're talking about? And
was it fertilizer? I forgot. Yeah, I thought it was a crop, but
and then they realized very quickly, which I 100% predicted, that they're like, oh crap, we don't have enough crap. We don't have enough. There isn't enough fertilizer, manure to go around. They had to their infrastructure, their agriculture was collapsing. They had to emergently, suspend the rules and allow for the use of artificial fertilizer.
It was a catastrophe.
It was a catastrophe.
Yeah.
It was total. And it was 100% predictable. It was 100% predictable. Half of our food is fertilized by manure. The other half is artificial. You can't get rid of one or the other, right? We need both. Yeah. We can't just cut our food supply in half. So you can't get rid of all of the animals that are producing the manure, right, without shifting over time and replacing that as a source of fertilizer. And you can't just ban half of the fertilizer, that we're using to grow our crops either, and think that we're going to just magically double our manure production. How's that going to work? You have to, I was reading a good article today about economics, because of the shenanigans that are going on. And the main point was that you have to understand modern economics as a global ecosystem. That is the only way to understand it, right? That all of the
so intertwined.
All of the old thinking, the Adam Smith kind of thinking about economics is obsolete now. You know, like, and they made the point to emphasize that it's like no single country on the planet can produce an iPhone. There isn't a single country that has all of the infrastructure necessary to produce an iPhone.
Yep.
It can only exist as an ecosystem of supply chains and various expertise and various manufacturing capabilities.
Raw materials.
Yeah, the whole thing that has to come together requires this intricate web. You know, and agriculture is the same way. It's exactly the same thing.
It's a good way of looking at it.
Yeah, it's an intricate ecosystem. You can't just start willy-nilly pulling pieces out or banning things or disrupting it and think like it's not going to collapse. It's not going to cause a disaster. Because it is. We've talked about this too. This is like my fear for, like, if civilization's going to collapse, how's it going to happen? I think this is how it's going to happen. These intricate ecosystems are only going to get more complicated and interdependent and vulnerable to disruption. And a cascading disruption of this economic ecosystems can, cause tremendous disaster. Not maybe the literal collapse of civilization, but I'm saying that's kind of, a significant disruption in services.
Well, I mean, let's hope that...
What?
Well, let's hope that when these things start to emanate and become reality, they course correct and say, okay, we got to stop this. We throw the brakes on, go back to, the way things were.
And that will happen. That will happen, in my opinion. The only question is how much damage gets done in the meantime. How much damage will there be before the course corrections are made and until that parachute is pulled or whatever. That's the question. That's the only question.
I think there'll be so much finger pointing that by the time they realize it'll be too late.
Yeah, maybe too dysfunctional to course correct in time. So don't ban half of our supply chain for the agricultural supply chain. It seems obvious in retrospect, Actually, it was obvious prospectively, as many people pointed out. All right, Evan, give us a quote.
This week's quote was suggested by a listener, Duncan from New York, who wrote to us, and the subject line in the email was Barry Unsworth, quote. I had to look up who Barry Unsworth was. A fiction writer, an English fiction writer, award-winning writer. Never heard of him before, but in any case, he writes, Hey, Evan, I'm in the process of, he wrote releasing. I think he meant rereading. I'm in the process of rereading Sacred Hunger by Barry Unsworth and stumbled upon this quote in the prologue. Here it is. The kneading, K-N-E-A-D-I-N-G, by the way, the kneading of memory makes the dough of fiction, which, as we know, can go on yeasting forever. And he writes a beautifully poetic way to phrase the rewriting nature of memory and recall. So thank you, Duncan, for that suggestion. Yeah. And Jay,
yes,
it's bread themed,
I caught that. That's great.
Bread analogy here. So I figured you would like that as well, and you'd rise to the occasion.
Oh God. Waiting for that.
Come on. You couldn't expect me to walk away without saying something like it.
All right. Thank you, Evan.
Thank you.
And thank you all for joining me this evening.
You're welcome.
Sure, man.
Thanks, Steve.
And until next week, this is your Skeptic's Guide to the Universe. Skeptic's Guide to the Universe is produced by SGU Productions, dedicated to promoting science and critical thinking. For more information, visit us at theskepticsguide.org. Send your questions to info@theskepticsguide.org. And if you would like to support the show and all the work that we do, go to patreon.com/skepticsguide and consider becoming a patron and becoming part of the SGU community. Our listeners and supporters are what make SGU possible.